From a discussion of the different processes of heating and cooling of the atmosphere, it is clear that the temperature of any particular place depends primarily on the amount of insolation received there. The amount of insolation is largely determined by latitude. Thus, of all the factors controlling the distribution of temperature on the Earth's surface, latitude is undoubtedly the most important. Even in ancient times, the Greeks were conversant with the fact that the equatorial region is the hottest on the globe and that the temperature decreases polewards. It was on this basis that they divided the Earth into 5 temperature zones. They also considered as boundary lines of these temperature zones the Tropic of Cancer, the Tropic of Capricorn, the Arctic Circle and the Antarctic Circle. However, with the expansion of the horizon of the knowledge, it was soon realized that besides latitude, there are other important geographical factors which affect the temperature at a particular point on the Earth's surface and its worldwide distribution. Presently, there are hundreds of weather stations in different parts of the world where, besides other weather elements, regular temperature records are maintained. It has been found that like diurnal as well as annual variations, the spatial variation of temperature is very important climatologically. In fact, the regional variations in temperature are analyzed with the help of data procured from observatories established in various countries of the world. After going through this module, you will be able to understand horizontal distribution of temperature, annual temperature range, seasonal distribution of temperature. On maps, isotherms are commonly used to show the horizontal distribution of temperature. Isotherms are lines connecting points with equal temperature values, generally reduced to their sea level equivalents. Remember that on the continental or world map, the actual observed temperatures are never used. Instead, the temperatures are reduced to the sea level in order to eliminate the effect of altitude. We know that temperature decreases with altitude at rate of 6 degrees Celsius for every 1000 meters. Thus, if a place is situated at a height of 2000 meters with reference to the mean sea level and the actual observed temperature is 20 degrees Celsius, then the reduced sea level temperature of that place will be 20 degrees plus 12 degrees, which is equivalent to 32 degrees Celsius. The temperature data are plotted on maps only after necessary corrections have been made. These corrections eliminate the effect of altitude on the distribution of temperature and bring out in sharp focus the effects of other factors thereon. If this is not done, the temperature distribution in the mountainous regions would be so complicated that it will be impossible to map it. There are a number of factors that determine the horizontal distribution of temperature. It has already been pointed out that the effectiveness of insolation in heating the Earth's surface depends on latitude. We also know that there is a general decrease in the temperature from the equator towards the poles. However, if the effect of latitudinal variation in the receipt of solar insolation were the only control of temperature distribution, the isotherms on a world temperature map would have been exactly parallel to the parallels of the latitude. But in spite of the fact the isotherms generally trend east-west, they are highly irregular. The isotherms over certain parts of the globe are closely spaced. This is clear proof of the wide variation in the temperature gradient in various parts of the world. Besides the isotherms showing the distribution of temperature, develop a number of bends and deformities in shapes. Following are the additional factors that also affect the distribution of temperature on the Earth's surface. Firstly, differential heating of land and water. Next, effects of ocean currents. Thirdly, mountain barriers. Fourthly, topographic relief. Mean annual temperature distribution. While discussing the average annual temperature distribution of the globe, it should be kept in mind that the mean value of the annual temperature of a place is of little significance climatologically because it is simply the mean of the seasonal extremes. The equatorial regions, however, are an exception to this general rule, for there is little annual variation in the temperature in these latitudes. The highest temperatures are found in the tropics and subtropics, which receive the largest amounts of insolation all round the year. On the contrary, the lowest average temperatures are recorded in the polar regions, where the amount of solar energy received in the course of year is very small. The isotherms within much of the tropics are widely spaced. In other words, the north-south temperature gradients in the lower latitudes are rather insignificant. The isothermal lines generally extend east-west, giving an evidence of the dominant control of latitude on the horizontal distribution of temperature. However, the isotherms are relatively more irregular in the northern hemisphere than the southern hemisphere. The dominant control of latitude on the temperature is more clearly seen in the southern hemisphere because of the preponderance of water over land. The isotherms, while passing from continents to oceans, get distorted at their margins. The magnitude of deviation in the east 6 degrees Celsius west trend of the isotherms is larger in the northern hemisphere, where there is a larger percentage of land surface. In the eastern part of the North Atlantic, the isotherms show a larger amount of odd deviation towards the north due to the combined effect of the warm ocean currents of the Gulf Stream and the North Atlantic Drift and the southerly winds. Similarly, bending of the isobars towards the pole is seen in the northern Pacific because of the presence of Kuroshio warm ocean current and the North Pacific Drift, as well as the prevailing westerlies. Whenever there are cold ocean currents, the isotherms bend towards the equator. The impact of the cold currents like the Labrador currents, cold currents, Benguela cold current, Californian cold current and Humboldt current, the coldest temperatures in the winter and the highest temperatures in summer are found over the continents. This is obviously the result of differential heating of land and water. It may also be noted that since temperatures do not fluctuate as much over water as over the land, the north to south migration of the isotherms is greater over the continents than over the oceans, especially in the middle latitudes. The western coastal regions of North America and northern Europe are warmer than their central regions. On the contrary, the tropical western coastal regions of Africa, Australia and South America are colder than their middle parts. The belt of high mean annual temperature, 26.7 degrees Celsius and above, varies in width in the tropical regions. It attains the maximum width over the continents. The northern hemisphere, being the land hemisphere, is warmer than the southern hemisphere. The thermal equator is found north of the geographical equator. The temperature gradient is very steep in larger, higher latitudes as well as along the eastern margins of the continents. The mountain ranges seem to exert great influence on the horizontal distribution of temperature. The barrier effects of Rockies in North America and Andes in South America do not allow the oceanic influences to penetrate far inland. Since the Himalayas in Asia are oriented in east to west direction, there is packing of isobars near them. Since January and July represent the seasonal extremes, the horizontal distribution of the temperature in these 2 months only is described below. Distribution of temperature in January. The horizontal distribution of mean temperature in January. Because of the preponderance of land in the northern hemisphere, the isotherms are more irregular and closely spaced here. On the contrary, because of the larger percentage of water surface in the southern hemisphere, the Earth's surface is more homogeneous there. This results in greater regularity in east to west trend of isothermal lines in that hemisphere. The isotherms are relatively more symmetrical while passing from the continents to oceans in the southern hemisphere. The northern hemisphere has larger number of isothermal lines than the southern hemisphere. On the continents of the northern hemisphere, the isotherms for the month of January bend sharply towards the equator. This clearly indicates that the cold polar winds lower down the temperatures of even more southerly regions in the hemisphere. Because of the effect of continentality, the winter in the interior of the continents is more severe. On the other hand, the isothermal lines on the oceans exhibit a poleward bend, showing thereby that within the same latitudes, the oceans in the northern hemisphere are relatively warmer than the continents. This is quite natural because the land surfaces cool more rapidly and to a greater degree than the water surfaces. In January, the coldest place on earth is found in northeastern Siberia. Another coldest region lies in the Greenland. In the middle latitude regions, the western coastal regions of continents are warmer than the counterparts on the eastern side. This is primarily due to the fact that the prevailing westerlies carry warmer temperatures from oceans towards the coasts. The close spacing of January isotherms over the continents in northern hemisphere represents a steep temperature gradient. The temperature gradient on the eastern sides of North America and Asia has been calculated as 1.5 degrees Celsius per latitude, while on the western sides of these continents the temperature gradient is reduced to the value of 0.44 degrees to 0.55 degrees Celsius only. The mean January heat equator is located to the south of the equator. In this month, the belt of highest temperature on the Earth's surface is located on the continents in the vicinity of latitude 30 degrees south in the southern hemisphere. In January, the effect of warm ocean currents on the horizontal distribution of temperature is well marked over the oceans in the northern hemisphere. These warm currents cause the isotherms to deflect more towards the pole. At this time of the year, there is a larger contrast in the temperature over the continents and oceans in the northern hemisphere. January being the month of summer in the southern hemisphere, the isotherms are rather straight in the hemisphere. Distribution of temperatures in July. The horizontal distribution of temperature in July. The isotherms in the northern hemisphere, where it is summer, are most irregular and zigzag. On the contrary, the isotherms in the southern hemisphere, where it is winter, are relatively more regular and straight, except at the edge of the continents where there is slight bend towards the equator. An elongated and extensive belt of high temperature, about 32.2 degrees Celsius, is seen extending from northern Africa through southwest Asia to the northwestern part of Indian subcontinent. Another belt of high temperature is found in the southwestern part of the United States of America. In July, the low temperature belt of the cold season now disappears from the northeastern part of Siberia. This region, because of the effect of continentality, becomes warmer than the other regions within the same latitudes. In the northern hemisphere, the continents are much more warmer than the oceans, which are relatively cooler. The maximum amount of temperature contrast is found between the northern Pacific and the adjacent land areas. During the northern hemisphere summer, there are lesser number of isotherms and they are widely spaced. With the apparent movement of sun towards the Tropic of Cancer, all the isotherms are displaced slightly towards the north, but there is little variation in their general tendency. In July, the thermal equator is displaced to the north of the equator. Another noteworthy feature of the July isotherms is that over continents they bend towards North Pole and over the oceans they bend towards the equator. Temperature gradient in the interior and eastern margins of the continents becomes weak. There is no substantial change in temperature gradient along the western margins of the continents. The difference between the warmest and the coldest monthly means is called the annual range of temperature. It varies greatly from place to place. There is a time lag also. Usually, the lowest monthly mean occurs a month or on occasions 2 months after the winter solstice, while the highest monthly mean generally occurs a month or two after the summer solstice. January and July generally represent the extreme months. Controlling factors. The following are the factors that affect and control the annual range of temperature in the same way as they do the horizontal distribution of temperature: latitude, height above the mean sea level, ocean currents, prevailing winds, precipitation, cloudiness, local relief, and distance from the sea. Latitude. The height of the midday sun is never less than 66.5 degrees at the equator, Twice in a year, the sun rays are vertical at the equator. Thus, the temperature is uniformly high in the equatorial region and the annual range of temperature is negligible. But from the equator to poleward, there is a progressive decrease in the temperature. It results in greater annual range of temperature. In the polar regions, where the length of day and night is 6 months, one should expect the highest annual range of temperature. But the fact is otherwise. Because the low angle of incidence of the sun's rays does not allow the temperatures to rise to higher values, besides, a larger part of the insolation received in the polar regions is expended in melting the ground snow. This factor also checks any substantial rise in temperature in those regions. Therefore, mid-latitude regions where the seasonal variation in temperature is greatest record the highest annual range of temperature. Height above the mean sea level. The annual range of temperature at a particular place is largely controlled by the height of which the place is situated. At high elevations, the rarity of the air, larger amount of precipitation and cloudiness combine together to lower down the average temperature even during the warmer months of the year. But the mean values of temperature for the colder part of the year are not affected by these factors to same degree. Thus, places situated at higher elevations have lower annual ranges of temperature. Ocean currents. The effect of ocean currents upon the temperature of adjacent land areas are variable, depending on the direction of the prevailing winds. Where the prevailing winds are onshore, they carry the moderating effect far inland. Under these conditions, the warm ocean currents help to raise the temperatures of the adjoining regions. Prevailing winds. Among the factors that have controlling influence over the annual range of temperature, the prevailing winds are the most important. Offshore winds bring about an increase in the annual range of temperature of the adjacent land, while the onshore winds carry the moderating influence of the oceans far inland and impose a restriction on the annual range. The effect of ocean currents is largely determined by the direction of the prevailing winds. Onshore winds carry their influence to the coastal regions, while the offshore winds deprive them of the warming or cooling effects of the ocean currents. Precipitation and cloudiness. In those regions where the rains are falling or where the skies are covered with clouds, the summer temperatures are relatively lower. But during the winter, the clouds check the loss of heat by terrestrial radiation. Thus, in cloudy regions, the winter time temperatures are not allowed to fall much. Therefore, in such regions, the annual range of temperature is relatively smaller than those regions where the weather is clear and dry. Local relief. Slope is one of the most potent factors which affects the temperature of a place. The slopes facing the sun have higher temperatures during the summer months, and the slopes protected from the sun have much lower temperatures during the winter. Thus, this local factor also affects the annual range of temperature. Distance from the sea. Water is heated or cooled in a longer period of time than the land. Because of this peculiar characteristic of water, the coastal areas enjoy a moderate climate, and difference in the temperature of the warmest and coldest months is not very large. On the contrary, the interior locations have extremely hot summers and cold winters. Thus, with increasing distance from the sea coast, there is a corresponding increase in the seasonal variation of temperatures. However, in the vicinity of the equator, the effect of distance from the sea on the annual range of temperature is quite negligible. Its effect is more marked in the temperate regions. It may be pointed out that since the coastal locations have larger amount of clouds and the resultant precipitation, the diurnal range of temperature is also very small. The following are the salient features of the annual range of temperature. Firstly, the annual temperature range is characterized by variations over different parts of the globe. The annual range is lower in the low latitudes and higher in the higher latitudes. In the same latitudes, it's higher over the continents and lower over the oceans. But in northern Pacific Ocean, the annual range becomes larger as the distance from the equator increases. In North America and Asia, the interior regions are characterized by higher annual range, while the coastal areas have smaller range. In fact, the magnitude of the annual range of temperature depends on the size of the land masses. Because of the vastness of the continent of Asia, eastern Siberia has as much as 55.6 degrees Celsius annual temperature range. Within the tropics, the continental interiors have larger annual ranges than the adjacent oceans. This is evident when the July and January isotherms for the tropical deserts are compared. In the middle latitude, at latitude 60 degree north in Siberia, the mean temperature for January is 34.9 degrees Celsius, while in the same latitude, the mean temperature for the same month over northern Atlantic is 4.4 degrees Celsius. This is a typical example of the effect of differential heating of land and water. The highest values of the annual range of temperature are observed in the interior regions of the land areas in the temperate zone. In the southern hemisphere, where the land area is limited south of the Tropic of Capricorn, the annual range of temperature over the oceans is only 5.5 degrees Celsius, whereas it is 16.7 degrees Celsius in the continents of South America, South Africa and Central Australia. This also shows the effect of oceans on the annual range of temperature. If we look at the mean temperature distribution maps for the months of January and July in Eurasia, one more characteristic feature of the annual range is clearly discernible. The annual range of temperature increases from west to east on this huge continental landmass. So today we have learned about temperature. Temperature is said to have great environmental significance because it determines the magnitude of the thermal stress which human beings as well as plants and animals are subjected to. Thermal stress is small in the equatorial region where the annual range of temperature is insignificant. On the other hand, in the subarctic zone, it is severe because of the higher annual range. Such climates have small thermal stress are said to be equally climatically.